Hello my friends. Today I want to find x from this equation. Maybe you remember from mathematical equations when you have a to the power of m times n, you can write it like a to m and the whole term to the power of n. We have the same situation here for the first equation because the first term and the second term is very similar and we can make it more same. For this one, 2 to the power of 3 times x is like 2 to the power of x, like that, to the power of 3. Because 3 times x is like, based on this equation, could be right like that. And second term is 2 to the power of x equals 10. But it's very helpful if you let 2 to the power of x, because they are same in both terms, as a parameter like y. I name it y here and rewrite this equation again based on this y. Now y cube plus y equals 10. And now it's very simple, but the order is 3 and it's not very easy to solve it. We can use a lot of ways to find the value of y. Maybe you find another way, or maybe a simpler way, or a creative way, but I have my own way here. Maybe if you have another way, please leave a comment for me. And don't forget, please subscribe my channel, because a lot of such these problems you can find in my channel. It would be very helpful for you. And we can use our argument in the comments for improvement my channel. Now I can show you what is my solution here. Y, it's a simple y, but you can write it as, I can write y as minus 4y plus 5y. You agree? It's a bit strange, but you can see in the further why I choose this expression. Maybe you can choose another pair terms or something else. But based on mathematical identities, it will be very simple to choose this pair to define this expression. Now I can pair these terms with each other. Y3 now minus 4y, because I want to pair this minus 4y with this y cube, plus 5y, and this summation for these two terms is simple y. And I take this 10 to the other side and flip it sign. Now I have two pairs, this pair and this pair. I put it in parentheses because you can find out the way easily. For the first pair, I have y same, so I can factor out it. Y, and what remains from the first term is y squared minus 4, close parenthesis. And for the second pair, you just have 5 in common, so you can factor out 5 and then y minus 2. Okay, now I write for you the mathematical identity we use here. You know, when a squared minus b squared, you can write it as a minus b times a plus b. The same situation you can see here, because 4 is 2 squared, and exactly this expression repeated here. So we can use this result for this expression here. So I write the rest here. Y, and for this I replace this term here, y minus 2, because 4 is 2 squared, times y plus 2, second one, and the rest, plus 5 y minus 2, and finally equals to 0. And now you can see why I choose this per the first step, because we have now y minus 2 in common in both terms. You can simply factor out this y minus 2. Y minus 2 I factor out. From the first term, you only have y times y plus 2. And from the second term, you only have 5. Close the bracket and equals to 0. Now we can solve this equation very easily. I arrange this part to go further with this equation. Now you have two terms multiply each other, and the result is 0. Y minus 2 times these bracket things equals 0. And you know, if two parameters times each other leads to 0, then you can get result, have this result, one of them or both of them are 0. So either y minus 2 is 0, the first parenthesis, and and this bracket is 0. y plus 2 plus 5 is 0. These are two pairs of answers. For the first one, it's very easy. Y is 2. Okay, for the first term is very easy, and you can have this result. But for the second one, you have to multiply the first term. So is y squared, y 2y, and here is 5 is 0. You have a second order equation, and you can easily by the formula. You may remember. If you don't remember, please check my other videos. Minus 2 plus minus a squared. 2 squared is 4. Minus 4 times 1, 5 is 20 over 2 times. And this is the answer. And I write here minus 2. This is minus 16. And maybe you know minus 16 under radical is not the real one. And you have to write it as the imaginary numbers. So minus, I just write it here, minus 16 over 2. And minus 16 square root is minus 2 plus minus 16 is 4. And minus 1 is imaginary number I over 2. Okay. The second pair, the result is here. I can simplify it and write it here, because you know, over each other, minus 1 plus minus 2i. And this is the second pair. I erase here and write it simply here. Second term is, second pair of result is minus 1 plus minus 2 I. This is the second answer. Actually, two answers. Okay, now I have actually a real root, a real answer, and two imaginary answer. These are all of my answers, but what kind of answer we need, I can show you go further, because it's not the end. Because the first we let y as 2 to the power of x. Our goal is finding x, not y. So I just replace y in this first assumption and find x from that. I erase here again. Okay. 2 to the power of x is y. For the first answer, you have 2. So 2 to the power of x is 2. Okay, but so if y is 2, you can write it like this. And this 2 is 2 to the power of 1, you know. And when the base numbers are same, you can just decide, just equal the powers. X is 1. For the second answer, because from the first one, you find the solution x to, equals 1. But for the imaginary numbers, okay, I again replace the imaginary here. 2 to the power of x equals to a minus 1 plus minus 2i. Never, when base is a real and the power, everything, it could be imaginary or real. When you have this expression, never it equals to the imaginary numbers, because this one is always real. So this goes to nothing. So we can drop the imaginary solutions and just stay at our real one. Our result. The only result is x to the equals to 1. And that's it. You can check it very simple here. If you replace 1 in this equation, you can find the solution x. So check. If x equals to 1, this is 2 to the power of 3 plus 2. And 2 to the power of 3 is 8 plus 2 is 10. So check. It's true. It's correct. Thank you for your attention.